Hello, my name is Chris Hughes. I'm a CISO and co-founder at a company named Aquia, and I have about 15 years of cybersecurity experience ranging from public sector, active duty in the Air Force, prior civil service with the Navy, as well as GSA and the FedRAMP team, and now co-founder and CISO at a company named Aquia, as I mentioned. Today, I'm going to be giving a talk titled Securing the Software Supply Chain, Transparency in the Age of Software-Driven Society. So first, let's talk about the good of open source adoption. We know that open source adoption is on the rise. And there's various reasons for that. It expedites innovation, it avoids reuse, and lets people essentially speed their ability to get to production with innovative capabilities and technologies. And it also has a robust community and ecosystem and cross collaboration going across the many organizations across the ecosystem, whether you're talking public sector, private sector, many industries are all involved in open source. 97% of organizations are using open source software, and 77% of organizations have increased their use of open source software. And that said, 80% of organizations are actively sponsoring open source software projects. And the highest increases that we're seeing among open source software is DevOps and cloud native technologies. When you think of things like cloud, think of things such as cloud, Docker, containers, Kubernetes. That's where we're seeing a lot of capabilities come out around open source adoption and where we're seeing the biggest uptick. So the bad side of open source adoption, as I mentioned, there's a lot of valid reasons for open source adoption, whether it's reuse or expediting ability to deliver capabilities to production and get the speed to market. But on the negative side, there is definitely a negative aspect to it. Malicious actors are increasingly realizing that they can compromise, one aspect of the software supply chain and have a cascading impact across downstream consumers, whether that's an open source component like Log4j that many organizations are using in their products and software, or you're talking about something like a managed service provider or a cloud service provider. Any of those can have an impact on the software supply chain and have a cascading impact across many downstream consumers. And this is visualization from Fortress Security. It shows a great example of how we've seen an uptick in these activities. If you look, it's just over the last 2 years, there's many notable examples. Of course, we all know Log4j, but there's many other notable examples there that you can take a look at and see that we're seeing this uptick. And part of the issue here is that we know many of these projects are supported by unpaid volunteers. These maintainers in often cases are not paid to do the work that they're doing. And unfortunately, security is not often prioritized for that very reason. They're just interested in maintaining the project, you letting people use the capability downstream, but they're not necessarily prioritizing security remediations or fixes of the projects that people are consuming. And the issue here is we have a lack of transparency as well. I talked about this in my opening slide, but incidents like Log4j, for example, are sending organizations scrambling, trying to figure out, where am I using this open source component, this library, this dependency, for example, where is this in my ecosystem and how can I go about remediating it? Since many organizations are flying blind to this and don't have full visibility across their software supply chain and what they're consuming, they don't really know what's running in their environment and where to go ahead and start remediating that. So definitely couldn't have a talk on software supply chain without discussing some of the notable federal events that we've seen. Obviously, we had a cybersecurity executive order in May 12, 2021 that came out, and Section 4 of that was entirely dedicated to bolstering the supply chain security of the bolstering software supply chain security, I should say. And that Section 4 was fully dedicated to that, and there was many activities associated with that, pointed at NIST as well as other public sector organizations that were involved in this. And on that note, NIST had held several workshops for cybersecurity supply chain risk management. And they also published a new secure software development framework that has been published a few months ago at this point. But if you look at where things are headed, right now the federal government's on a trajectory where organizations like OMB and others are going to start to enforce that federal agencies only procure software from vendors that are attesting that they're complying with SSDF, the Secure Software Development Framework for NIST. So if you're a software producer and you're not familiar with this, you definitely need to go take a look at this. Many aspects of the SSDF are going to touch on software supply chain aspects, things that we'll be touching on in the coming slides, and how to bolster the software you're delivering to downstream consumers, whether you're delivering via cloud or you're delivering on-premise, traditional software. All these secure development practices should be touched on as you're going ahead and creating products or software for community use. And they also published an update to their 800-161 Rev 1 Cybersecurity Supply Chain Risk Management Guide. If you go take a look at that, Appendix F in particular has a real in-depth process and breakdown of what you should be doing when you're handling open source software security and how you can go about bolstering your organization's supply chain risk management around open source software. So as I mentioned, NIST has many activities underway, and SSDF is one among those. If you take a look at SSDF, it breaks down things that you need to be meeting from three different aspects of maturity: it has foundational, sustaining, and enhancing. This is doing this in this way because it understands organizations are not just going to jump from 0 to 100. You may not jump from no software supply chain security and maturity to doing enhancing practices, for example. So it gives organizations different levels of maturity to strive for. Starting off with foundational, just using basic SSDF, protection and response guidance, and ensuring that open source components that you're using are acquired via secure channel and trustworthy repos, for example, that you're consuming software from and components from. Moving on from there, if you look at the sustaining capability, it touches on things like software composition analysis on internal code bases to look for vulnerable components. It also touches on creating and maintaining internal repos of libraries and known good open source components, for example, for developers to use. So rather than having a situation where your developers are going out to the open internet, just pulling anything that they want to use from a component, library, dependency perspective, you've created an internal repository of known good resources that your developers can take and use for software development efforts. And then lastly, honestly, on the enhancing pillar, the most mature of the SSDF, it gets into things such as moving away from insecure programming languages and starting to use more native, more secure programming languages natively, as well as automating the pipeline of collecting and storing open source components from internal repos prior to the introduction for development environments. And we'll be touching on this in more slides coming up here. But if you look at some of the guidance coming out of the Open SSF and Linux Foundation software supply chain efforts, they also touch on the secure programming languages aspect of thing as well. So you couldn't talk about software supply chain without talking about SBOM. If you've been around this space for some time recently, you know that SBOM is getting a lot of momentum. First, it started off with NTIA, and they kind of championed the different use cases and minimal elements when it comes to creating an SBOM for production and give some guidance for consumers as well. That effort has now been moved over to CISA. And there's obviously a lot of other organizations involved in SBOM, some of the leading standards, SPDX by the Linux Foundation and Cyclone DX, of course, by OWASP, are putting out great information on the topic as well. So as I mentioned, CISA has now taken over the SBOM effort from NTIA. They held the SBOM Arama in late 2021, and they gave very interesting talks, from panels of experts, both from the government perspective as well as from the industry perspective. So I definitely recommend going and giving that a listen if you haven't heard it already. And they're increasingly looking to use, looking for software producers to provide SBOMs to software consumers downstream that are consuming software. So we talked about SSDF, for example, and third parties attesting to SSDF compliance. We'll now see federal agencies and honestly industry organizations as well starting to ask for SBOMs from software producers, and also producing SBOMs for their internally developed software as well as a best practice if they're in a position to better respond to the next 0-day, next log4j type incident, to understand what they have in their environment, where it's running, and how to go about remediating that. As I talked about, the three leading formats are SWID, Cyclone DX, and SPDX. But that said, SWID is largely for licensing. We're seeing Cyclone DX and SPDX take the most momentum when it comes to security use cases. So as I talked about, that recently there was a summit at the White House in January of 2022 that it had about 37 different organizations involved, if I recall, leading tech companies like Google and Microsoft and others, as well as industry organizations like OpenSSF and Linux Foundation. And then most recently in May, the Linux Foundation and OpenSSF actually published their open source software security mobilization plan. This comes out with 3 high overarching goals, which are securing open source software production, improving vulnerability discovery and remediation, and also shortening the ecosystem patching response time. And it has key focus areas. Each of those high overarching goals has several substreams associated with them, 10 different substreams at different focus areas, everything from education, digital signatures, actually establishing an OpenSSF incident response team so that if there is a notable incident in a large used project, for example, the OpenSSF team can jump in and assist with that and go ahead and help try to remediate that and minimize that downstream impact on the consumers. There's also an entire section dedicated to SBOM. As I talked about, SBOM is gaining more and more momentum, and it really dives deep on that in that plan. If you go take a look at it, there's a lot of depth around SIG-Store as well. If you look at digital signatures, ensuring that we have attestation and digital signatures, so we have integrity throughout the software supply chain, and we have a visibility of what we're consuming, where it's from, who signed it. If it has some level of non-repudiation and integrity associated with it, we're able to ensure that we're consuming what we believe to be consuming and from a trusted source. Also, they have another aspect in there of establishing risk assessment dashboards. So they're going to take a look at the 10,000 most used open source software projects and establish risk assessment dashboards to give you insight into what is the risk of these leading open source projects, and you understand what you're consuming downstream from those projects and the risk associated with them. So that's a great industry resource that'll be really valuable across the entire ecosystem. So open source software adoption, what to do. As I talked about, we have guidance coming out from NIST, the Cybersecurity Executive Order, obviously NTIA and CISA, OpenSSF and Linux Foundation on the industry side of things. And all these organizations are putting out great information. So I definitely recommend starting out with NIST 800-161, revision 1. That's their cybersecurity supply chain risk management guidance. It talks about establishing a C-SCRM program. And then as I talked about, OpenSSF and Linux Foundation are great organizations to engage with. They put out a lot of great information around open source software adoption, establishing open source software security programs and having those kind of things within your organization to help champion those causes and drive down risk associated with consuming open source software. And as I talked about, the 800-161 has an Appendix F, which is fully dedicated to the Cybersecurity Executive Order and touching on, the different aspects of software supply chain security. It has the foundational, sustaining, and enhancing capabilities that we talked about earlier. And also, it talks about some of the things we touch on, such as software composition analysis, utilizing XBombs, and VEX, which is the vulnerability exploitability exchange. If you take a look at that effort, that's trying to give you information of not just what components are in software you're consuming, are they vulnerable, but also are they actually exploitable. So organizations that are producing software will be able to provide VEX information, metadata associated with an SBOM, to give consumers an understanding of, not just what vulnerabilities are in the software that we're consuming, but are they actually exploitable? That way you can make risk-informed decisions to drive down activities or drive down risk, associated with the software that you're consuming, and help you establish those hardened internal repos of open source software that you plan on using across your organization for your development efforts. So also I want to talk about CI/CD pipelines. As I talked about, open source software adoption is on the rise. Some of the areas where that's having the largest increase of use and innovation is around development tools, cloud native capabilities, and CI/CD pipelines, of course, is a big aspect of that, of how we deliver software in modern environments. But that said, CI/CD pipelines are not, a panacea, and they can be an attack vector themselves. If you take a look at SolarWinds, for example, if a malicious actor is able to compromise the software supply chain, the CI/CD pipeline, I should say, they can actually contaminate downstream consumers by implementing malicious activities in that CI/CD pipeline and then being consumed by downstream consumers. So some resources to check out on this front, Google started the Salsa project. If you go to salsa.dev, slsa.dev, you can dig into that capability. It has 4 levels of maturity, essentially, different capabilities that you're looking to implement in your software supply chain. And it has a lot of aspects that touch on CI/CD. So definitely go take a look at that and see what you can be doing to bolster your software supply chain efforts when you deliver in a CI/CD fashion, in a cloud native fashion. Also, Cider Security has an excellent top 10 CI/CD security risks resource. If you go dig into that, they've kind of done a lot of research to see, what are the top risks associated with CI/CD pipelines? How can we drive down these risks? What are some of the organizational security best practices that we could be implementing to drive down risk associated with CI/CD pipelines? So I definitely take a look at that. And Salsa, for example, touches on 3 key aspects, which is preventing tampering, improving integrity, and ultimately securing packages that are consumed by downstream consumers from the software supply chain. So both these are great resources. I fully expect Salsa to continue to grow in adoption and industry recognition. So be sure to dig in on those. No conversation of cloud native security or software supply chain would be complete without touching on Kubernetes and containers. We've seen a tremendous uptick on container adoption when it comes to deploying workloads in cloud native environments. And of course, Kubernetes has become the de facto container orchestrator of choice for many organizations, and for many good reasons. Kubernetes has tremendous benefits around efficiency, fault tolerance, scalability, etc. But it's not without its own concerns as well. But just some metrics on this, 75% of global organizations are starting to use containers. And as I mentioned, Kubernetes is de facto orchestration tool of choice. It's improving development timelines, improving costs, and ultimately driving scalability in cloud native environments. So there's many great aspects associated with Kubernetes, but there's many security concerns as well. Moving on to that, to touch on some of those security concerns, if you take a look at Palo Alto's Unit 42 Threat Research Group, they found that 99% of Kubernetes Helm charts in Artifact Hub have insecure configurations. And in public container registries such as Docker Hub and Google Container Registry, for example, 91% of the images have critical security findings associated with them. So while there is benefit from the open source perspective of being able to go grab a container, go grab an infrastructure as code manifest or Kubernetes manifest, many of these have insecure configurations or misconfigurations or vulnerable configurations associated with them. So you have to understand what you're consuming. Much like anything else that's code, you could be inheriting a lot of risk, a lot of vulnerabilities if you're not sure of what you're consuming and the risks and vulnerabilities associated with it. So some recommendations on this front is to utilize container and manifest scanning. So if you're pushing containers or Kubernetes manifest through a pipeline via GitOps type deployment models, for example, you want to be using scanning technologies to identify vulnerabilities before they become runtime vulnerabilities in a production environment. You want to use pre-hardened images, so ensure that you kind of have a repository like we talked about of internal code that you vetted and and have level of trust in. Same thing here. If you're using images, you don't want to just be going to grab images off the public web. You want to ensure you're using pre-hardened images that align with things like CIS benchmarks, guidance from CNCF or DoD's container hardening guide. There's also a Kubernetes STIG if you're familiar with DoD and the Security Technical Implementation Guideline. They have a Kubernetes STIG that goes ahead, it dives down deep in the weeds in terms of secure configurations of Kubernetes clusters and how to go ahead and ensure you're using those securely. And also, I want to mention that NSA has a great Kubernetes security hardening guide as well. Definitely worth checking out if you're working with Kubernetes in cloud native environments. Also, as I mentioned, not just scanning containers as they go through the pipeline, for example, but you definitely want to be scanning them throughout the life cycle. Say you have a container that has been scanned as part of the pipeline, but now it's running in production for some time. We all know that software ages like milk. The same can be said for containers. This compute abstraction essentially, as it's sitting out there, new vulnerabilities are being discovered. So maybe it wasn't something identified in the pipeline, but now that it's running in production and it's been, some days or weeks, for example, maybe there's some new vulnerabilities associated with that. So you definitely want to be scanning things in runtime as well, not just in the pipeline. And ultimately, you need to update your incident response plan, your business continuity plan, your playbooks associated with your organization to account for Kubernetes and containers. If you have an incident and you really haven't went through tabletop exercises or even game days associated with incident response for cloud native environments and containers and Kubernetes, it could be a really problematic and challenging situation trying to respond to those if you have no processes and policies in place, you haven't practiced anything like that. It can be very disruptive to the business. And ultimately, these insecure configurations that existing in infrastructure as code and Kubernetes are just like software, for example. As we move to everything as code, Kubernetes, infrastructure as code, these things all have vulnerabilities associated with them as well. So you definitely want to be scanning those artifacts and the resources before putting them in a production environment. So why, I put a little plug here for Tidelift as well. A lot of the recommendations I talked about, such as establishing, internal repositories of hard and known components to use across your organization for developers to use, libraries, dependencies, components, etc. Tidelift helps facilitate that. It could be a big lift for your organization to do on your own without the appropriate resources. Tidelift provides, a robust platform to go ahead and facilitate that. So you're not trying to create these capabilities from scratch. Also, another really innovative approach that Tidelift has, as I mentioned, many of these projects are maintained by unpaid or underpaid volunteer type resources maintainers. Tidelift takes a look at the environment, the ecosystem, and sees what some of the most used projects are, and they go ahead and try to provide a compensation model essentially, so that maintainers of these projects who are being used by many organizations across the world have a compensation model in place so they can drive security fixes, they can drive improvements to the projects, and they ultimately have a compensation model driving incentives to make the project better. Also, as I talked about, creating that internal catalog of resources. Tidelift can help facilitate that by giving you a curated catalog of project health and vulnerability insights, so you understand what software we're using, what are the risks and vulnerabilities associated with it. You can also create SBOMs for the software you're consuming, and managing those SBOMs at scale is very challenging as well without a native capability. This is another area where Tidelift is really thriving and providing innovative services to the consumers and organizations using them. And as it said, the name is super catchy. I couldn't get past this piece. As it says, a rising tide lifts all ships. Tidelift is looking to do that across the open source software ecosystem by providing these capabilities. Like I said, the hardened internal repositories, creating SBOMs, being able to store those and act on those at scale, understanding as an organization, what does our software consumption look like, and how can we drive down risk associated with that? So with that said, that's my talk. Thank you.